Okay, this is the video for the case center problem. So in the previous set cover problem, we chose to locate a minimum number of ambulances so that every site was covered by an ambulance within an 8-minute response time. And it chose to place an ambulance at sites 2 and 3, which meant that the movies were 8 minutes away from an ambulance. And so one may ask, could we do better? And actually, in this particular instance, we're going to allow ourselves to place 3 ambulances. Okay. So otherwise, the setup is the same. The same response time matrix here. We can go ahead and define our sites as we did before. And we're locating 3 ambulances. That, make sure it looks good. Okay. Okay, so let's go try to build the model. So as usual, gp.model. So our variables are going to be a little more complicated now. So we'll need these assignment type variables. So from every site to every landmark, we'll define a binary variable. We'll also define, before we get to that, maybe I should give the interpretation of this variable. So this xij variable equals 1 if site I covers assigned to then we also have these binary variables for each of these sites. That tells us yes or no, do we place an ambulance there? So it's 1 if an ambulance the last variable is used to represent the worst case response time. That's just a single variable, and we can define it as continuous. Okay. Doesn't like that. What did I do? Okay, it's a single variable, so it should be add var. Okay. So our objective is pretty simple. So this is actually minimize the worst case response. This is just z. Right. We require this constraint that we locate precisely k ambulances. We require that each landmark is covered once. So for each landmark j, we sum over all of the different sites that could potentially cover it. And then we have those same sort of coupling constraints that we oftentimes have. Don't place a factory or an ambulance or something at site I, then you can't use it. Okay. Eventually we'll need that m.dot update. I want to write that before I forget. And then this last set of constraints says that the response time for each landmark J is at most that worst case response time. So this is really the only constraint or set of constraints where we start referencing that Z variable. We have multiple constraints. We have one for each landmark. And the constraint says that the response time for J is at most the worst case response time, which we denote by Z. And that response time landmark J, we can say that's the time in minutes site I to service J times the decision of whether or not I covers J. And we have to sum that over all different choices of sites. So again, only one of these x variables in this sum is going to equal 1. All of the other ones will equal 0. And so whichever one of these equals 1, we'll end up paying for that time for that response. Okay. Good, let's give that a go. Okay, seems to work. Let's try to solve. Okay, and we get a 5-minute response time. We could either query z.x or we could query m.predicted value. And then we'll also want to know where are we placing ambulances. So just in this case center problem, that's what we're trying to illustrate here. So the centers are a set of sites I, for which that y variable is 1, which we check by comparing against 0.5. So it tells us to put ambulances at sites 3, 4, and 5. And supposedly that will ensure a 5-minute response time. So let's check that. So 3, 4, and 5. So the airport's covered by 5. Boomer's covered by 5. Hideaway actually is covered twice within a 5-minute response time, as is Couch Park. Movies are covered by this one. Edmund Lowe is covered by site 3. Okay. Now, if we were curious, we could rerun this model. So instead of having those 3 ambulances, what if we only had 2? What would happen? Could we get that 5-minute response time, or is it going to be longer? No, it is 5 minutes. So just by placing ambulances at sites 1 and 3, we could get our 5-minute response time. So 1 and 3, so the airport would be covered by 1, Boomer by 1, Hideaway by 3, Couch by 3, Movies by 1, Edmund Lowe by 3. So it looks like the Movies and Edmund Lowe are the ones that are getting this bottleneck of 5 minutes. And in fact, for Edmund Lowe, that's the quickest we could get among those 5 sites. So that seems like a a natural lower bound on our objective. Like we'll never, or I guess a natural upper bound on our objective. We'll never be able to do, well, I guess both. We'll never be able to beat 5. That's what I mean. Interesting. Okay.